Hello, chemistry. I, Miss Aninga, and I saw some people were having some trouble on their mole practice number 1. So I thought I'd jump in here and see if I can't help a little bit. So specific ones I saw were how many moles are in like 48 grams of NaOH, as well as things like how many particles are in each. So I can do a couple of these. I'll go over molar mass when we're talking about this one. And then I know people were asking about the last one. So I can go over all 4 of those, okay? So first off, the mole. A lot of you might not be able to understand what a mole is or wrap your head around the idea. But a mole in chemistry, you can also call it a mole without an E, is just like a dozen. It's just another indicator or word or quantifier for a number. So for instance, we all know what a dozen is, right? A dozen is 12. Half dozen is 6. A baker's dozen is 13. That kind of thing. A mole is just another way to quantify a number by saying the word instead of listing out the number every single time. So a mole, all it is the number 6.022 times 10 to the 23rd things. So if I had, say, a mole of grains of rice, I have this many grains of rice, okay? If I had, say, a mole of, like a mole of eggs, I have this many eggs. Okay, when we're talking about chemistry, when we say I have a mole of, say, oxygen, it means I have a mole, this number of oxygen molecules. Okay? Now, the way the mole works is, thankfully, our mole is connected with our periodic table wonderfully, in that is also our atomic mass. Okay, so when we look at our periodic table, if I had a mole of carbon atoms, I have this many carbon atoms. The weight of that many carbon atoms is 12.011 grams. Okay? So 1 mole of any of your elements is your atomic mass. So keep that in mind, that your molar mass is connected to your atomic mass. Okay? Keep that in mind when we're going through our mole practice. Okay? I'm going to go through these 2 here. First of all, number 1, how many particles are in 1 mole of water? 1 mole of anything, if you replace mole with dozen, how many particles are in 1 dozen, like a dozen water molecules? You'd say there's 12 of them. How many particles are in 1 mole? that's going to be this number. There's 6.022 times 10 to the 23rd particles. Now, when I say particles, I just mean molecules. So then we apply that to this down here. How many particles are in 2 moles of NaCl? It doesn't matter what the substance is. We just need to know how many particles are in 2 moles of it. If this is 1 mole, similar to saying how many eggs are in 2 dozen, eggs in a 2 dozen carton. There's 12 plus 12, or 12 times 2, right? So there's 24 in 2 dozen. If there's 2 moles, we just have to take 6.022 times 10 to the 23rd and times that by 2 moles, because we have 2 moles of it, and get our answer. If you're having trouble with these, remember to use Desmos. Otherwise, you can do it on your calculator, on your phone, or at least on your iPhones, I believe you can. If you turn it to the side, you get your scientific calculator. I believe you can do it like 6.2022 times 10 to the 23rd. So that's what it reads. And then you can times that by 2. And you get that big, nice long answer, which is 1.20. I'm just going to round it to that, times 10 to the 24th. Okay? And that's still just particles. Just going to say part to make it easier. Now, this one down here, it says how many particles are in 0.5 moles. Okay, 0.5 is half. So how many eggs are in a half dozen? There's 6. So how many are in half a mole? Half a mole is simply this thing times 0.5. So 6.022 times 10 to the 23rd times 0.5, or you could do divided by 2, that works too. So I'm going to just do divided by 2 for my last one to get my number. Back my 6.22 times 0.5, and instead we get that number right there instead, which is 3.011 times 10 to the 23rd. Now that number may seem strange to you, but remember we're dealing with really, really, really big numbers, and so it's okay. You might question yourself on the time to the whatever power, but that is right. Divided by 2. Oops. Sorry. Yeah, that's the number that you get. Okay. Same thing with up here. It's similar to this, where all you have to do is times this number by 14. This one, how many moles are in that many molecules? This one you might think is strange, but all you have to do for this one is understand that 1 mole is 6.022 times 10 to the 23rd. You have 4.3 times 10 to the 22nd particles or things. All you have to do is see how much this is out of that. So you got to do simple math. What is that? So 4.3 times 10 to the 22nd, that's how many you have. And you have to divide it by this is 1 mole, and you'll get your answer. And then you'll just put how many moles, because moles. Or in other words, down here is particles per mole. Up here is how many moles you have, so that those two cancel out, just give you, oh, sorry, this is particles, parts per mole, so these two cancel out, leaving moles to go forward. Yeah. For this one, for how many molecules are there in 48 grams of NaOH? So I'm just writing down my mole again, and my my green marker is losing some ink there, so I'm going to switch over to my brown marker here. So how many molecules are in 48 grams of sodium hydroxide? So first of all, this one's a two-step parter because we need to know two things. Number one, what is the molar mass of NaOH? And then use our grams here to figure out how many moles of that we have. So first off, NaOH, we had to figure out its molar mass and figure out how many moles is 48 grams of it. Okay. So luckily we need to break up this and figure out the pieces of it. So number one, Na, how many of them do we have? So this is the atomic mass. How many of them do we have to get a total? Same thing with oxygen. What do we got? We're getting a little pause there. I had to help out a student who came in to see me. But anyway, same with oxygen. We have to figure out what its atomic mass is, as well as how many there are to get a total. And with hydrogen. So if we break down our formula, we see that we have 1 sodium, 1 oxygen, and 1 hydrogen. Okay. Our atomic mass, we need to use our periodic table for. So if we yoink that out, take a look. Hydrogen is 1 gram per mole. Oxygen, sorry, let's go to sodium since we're here already. Sodium, we're going to go to 23 grams per mole. And then oxygen is 16 grams per mole. Because remember, our molar mass is connected to our atomic mass. 1 mole of any of these is their atomic mass. So grams per mole, grams per mole. We have 1 of them in here, which means we have 1 mole of that. So we have 23, 16, and 1 in total. We have, so in total, the molar mass of sodium hydroxide is 23 plus 16 plus 1, which is, if we do it longhand, 6 plus 3 is 9, plus 1 is 0, or 10, carry the 1, 2, 3, 4, and 0. So it is a total of 40 grams per mole. Now we have to go back to where we started. We have been given 48 grams of this. How many moles is this according to the molar mass? 48 divided by 40 grams per mole for that is going to give us our answer of how many moles we have. Which means we have 48 divided by 40 grams per mole means we have 1.2 moles of sodium hydroxide. Okay. Once we have our 1.2 moles of sodium hydroxide, then all we have to do is turn this back into molecules. Okay. And we know that 1 mole is this many molecules. Okay. So all we have to do is times this by another conversion factor, which is we have 1.2 moles and we know that 1 mole is 6.022 times 10 to the 23rd molecules. So when we do that, our moles cancel out and will give us our answer down here, which is, let's see, let's get on Desmos here. We just have to take our mole and times it by 1.2, and then you can see there it gives us our amount of molecules, which is 7.22 times, well, 23 since it's a 6 there, 7.23 times 10 to the 23rd molecules. Okay. So that is your answer for what you put into your practice. So put down 1.2 moles, and then that changes into 7.23 times 10 to the 23rd molecules. Okay, so that's the answer to that one. But yes, for these you have to figure out the molar mass first and then divide the amount that you're given by said molar amount to get how many moles there are. Okay, so molar mass, again, these are pretty easy, except for the ones over here, you have to determine the formula of them because it's practicing what we learned last time. The correctness of your answer will determine if you can figure out the correct formula. Granted, you can always look it up on Google, but that's not always going to help you when you have to figure something out on a test on your own if you're here at school. So don't rely on Google all the time to figure these out. If you need help with those and review them, please do so by looking back at what we did for our previous unit. And previous units, excuse me, not last unit, but the unit beforehand, when we talked about ionic and covalent bonding. Okay. Moving on to the very last one, which says how many grams are in 4.63 times 10 to the 24th molecules of carbon tetrachloride, better known, I believe, as, I have no idea actually. So we are given the amount of molecules, which is, we have 4.63 times 10 to the 24th molecules. You can think of these as particles. Either way. And we know that this is, we know we have, we're given CCl4. Okay, we want grams. Okay, so this one here is, the reason it's at the bottom is because it is a little bit of a challenge problem, where we need to take what we have in particles and change that into moles, and then transfer those moles into grams. Okay, so follow me here on this one. First of all, we take what we got, and we have to figure out how many moles this is. Okay, so, and as we had, so we have 4.63 times 10 to the 24th particles. Okay, that's what we start with. And we know that 1 mole is equal to 6.022 times 10 to the 23rd particles, or, pieces. Okay, so we have to do one conversion to start off with to leave us with moles, because that's going to get rid of the parts. So we'll do that first. So I'm going to use Desmos here. Let me find Desmos here. Just give me a second. There we go. So we got Desmos up here, and so we're going to fill this out. So we have 4.63 times 10 to the 24th particles. And we're going to divide that by our 6.022 times 10 to the 23rd. No. To the 23rd. Particles. Come on. To get how many moles of this substance we have. So we have 7.69, say, moles of CCl4. Now, since we know what moles we have, now we can figure out what that is in grams by looking at the molar mass of CCl4. So 1 mole of CCl4 should equal how many carbon what our carbon is. It's atomic mass times how many we have to get a total. Same down here with chlorine.